Welcome to Tech Lab by Sid. What is firewall in computing? In computer science, a firewall is a security system designed to monitor, filter, and control incoming and outgoing network traffic based on predetermined security rules. Its primary role is to establish a barrier between a trusted internal network, such as a corporate intranet, and untrusted external networks, such as the Internet, protecting the internal network from potential security threats. Firewalls are critical in enforcing security policies by blocking unauthorized access while permitting legitimate communication. They can operate at different layers of the network stack, such as the network layer, transport layer, and application layer, each offering varying levels of protection and control. Key terms and concepts related to firewalls. Packet filtering. This is the most basic form of firewalling. The firewall examines packets, or data units, that attempt to pass through the network and filters them based on pre-configured rules. These rules can include criteria such as source and destination IP addresses, source and destination ports, protocol type, example, TCP, UDP. Direction of traffic, that is inbound versus outbound. A packet that meets the firewall's filter criteria is either allowed or blocked based on its characteristics. Stateful inspection. Stateful firewalls are more sophisticated than basic packet filtering firewalls. They keep track of the state of active connections, that is, whether a particular packet is part of an existing, legitimate communication session. This allows the firewall to distinguish between legitimate packets part of an ongoing session and potentially malicious traffic attempting to bypass the firewall. Proxying, or application gateway. In a proxy-based firewall, the firewall acts as an intermediary between the internal network and the external network. It intercepts requests from users on the internal network and then forwards the requests to the external network. This allows the firewall to inspect higher-level protocols like HTTP or FTP for potentially malicious content, such as malware or unauthorized access attempts. Deep Packet Inspection, or DPI. DPI is a more advanced form of packet inspection that examines the contents of network packets, not just the header information. DPI can detect malicious content, such as viruses, worms, or other forms of malware by analyzing the data payload of a packet. This is used to detect attacks that might otherwise evade simpler packet filters or stateful firewalls. Next Generation Firewalls, or NGFW. Next Generation Firewalls combine traditional firewall functionality, that is, packet filtering and stateful inspection, with additional features such as application awareness, that is, identifying and controlling applications based on behavior, intrusion detection or prevention, cloud-delivered threat intelligence. SSL or TLS inspection. NGFWs are designed to protect against more sophisticated cyber threats that traditional firewalls might miss. Access Control Lists, or ACLs. ACLs are used by firewalls to define rules that specify which network traffic is allowed or denied. Each entry in an ACL typically contains an IP address range, that is, source and/or destination, port number for specific services or applications, protocol type, that is, TCP, UDP, ICMP, action, that is, allow, deny, Demilitarized Zone, or DMZ. A DMZ is a physical or logical subnetwork that sits between an internal network and an external network, typically the Internet. It is used to host public-facing services like web servers, mail servers, or DNS servers. A firewall may be configured to allow restricted access to the DMZ while blocking direct access to the internal network, adding an additional layer of security. Intrusion Detection and Prevention System, or IDPS. Some firewalls integrate with or include intrusion detection and prevention systems. These systems monitor network traffic for signs of suspicious activity or known attack patterns and can take action to block or mitigate threats in real time. Processes involved in firewall operation. Traffic inspection. The firewall inspects network traffic that attempts to enter or leave the network. This inspection involves looking at packet headers, that is, IP addresses, ports, etc., or even payloads in more advanced systems, like DPI. Rule matching. The firewall compares incoming traffic against a set of security rules defined by the network administrator. These rules specify what traffic is allowed, example, HTTP traffic from a specific IP, and what traffic is blocked, example, incoming traffic from suspicious IP addresses. Decision making. Based on the rule matching, the firewall makes decisions to either allow, block, or log traffic. The action taken is based on the severity of the rule match, whether it's a deny or allow rule. Logging. Many firewalls log traffic that matches certain conditions, particularly suspicious or malicious traffic. Logs can include details such as the time, source, destination, type of attack, and actions taken by the firewall. These logs are valuable for auditing, troubleshooting, and post-incident analysis. Alerting. In addition to logging, many firewalls can generate real-time alerts to notify system administrators about unusual or potentially harmful activity. Alerts may be triggered by specific types of traffic or by patterns associated with known cyber threats. Applications and use cases of firewalls. Network security. Firewalls are foundational in securing networks from external attacks, such as denial of service, or DOS, attacks, unauthorized access attempts, or exploitation of vulnerabilities. They ensure that only trusted traffic is allowed to enter a network, protecting sensitive information from being accessed or stolen. Corporate environments. In corporate environments, firewalls protect internal networks and enforce corporate security policies. For example, they may block access to certain websites or prevent employees from accessing the internet from untested devices. Cloud security. With the adoption of cloud services, firewalls are increasingly used to protect cloud-based infrastructure. They control traffic between on-premises networks and the cloud, as well as between different cloud instances, ensuring data security and compliance with regulatory standards. Remote access. Firewalls are also used to secure remote access to corporate networks. For example, a virtual private network, or VPN, may be used in conjunction with a firewall to secure remote user connections by encrypting traffic between the remote device and the internal network. Web Application Firewalls, or WAF. WAFs specifically focus on protecting web applications from threats such as SQL injection, cross-site scripting, or XSS, and other web-based attacks. They inspect HTTP or HTTPS traffic and apply rules that block malicious web requests. Intrusion prevention and detection. Firewalls can detect and prevent certain types of attacks by analyzing traffic patterns. For instance, they can block traffic coming from known malicious IP addresses or stop a distributed denial of service (DDoS) attack in its tracks. Home security. Firewalls are often included in home routers to prevent unauthorized access to home networks. They protect devices such as computers, smartphones, and IoT devices from being exploited by external attackers. In conclusion, firewalls are essential tools for maintaining the security and integrity of networks. They help protect against unauthorized access, cyber attacks, and data breaches by controlling the flow of network traffic. With evolving threats, modern firewalls are more advanced than ever, incorporating features such as stateful inspection, DPI, and integrated threat intelligence to provide comprehensive security across various layers of the network stack. Whether used in corporate, cloud, or home environments, firewalls continue to be a critical component of any cybersecurity strategy. Thanks for watching the video.